Okay, so any questions about anything so far? Anything we've done? Anything at all? Going once, going twice. All right, so we're on week 14. Week 14 is structures, and it's one of the few things that are left that I want to talk about in this class. And it's not too complicated. I have a bunch of examples for you today, and that's pretty much what the assignment is. Just go through these structure examples. And I also have the video posted from the Monday lecture. Look at that thing on top of this video if it doesn't make sense. So first of all, I have some examples of programs that use structures in here. Here's an example of a structure. Lines from 6 through 12 is a structure, right? The name of the structure is parts. It's uppercase just because, no particular reason. Normally, classes, objects, structures should start with an uppercase just to make them easier to identify. It's not required, but it's just a nomenclature. And what are structures? Well, it's just a way for you to group logically a bunch of properties, variables of something into a named entity, right? So you can have a structure for a human, right? And the property for the human will be maybe a string for the name, maybe an integer for the age, right? Maybe a float for the weight. You can have, just any kind of a real world thing, and you can group the properties of that thing into a structure just so that you can organize it and access it. And this way, if you have a structure human, then you can have, different named entities for the human structure. For example, one is going to be Alex with certain properties, one is going to be Heidi with another properties, right? Different people have different names, different weights, different age, right? So that's where the idea of these classes and structures come from. And we're not talking about classes just yet. We're going to talk about that next week, but that was one of the earlier limitations of the C language, and that's where C++ came in and they started offering object-oriented programming. And what are objects? Well, think of a structure, but then we're going to also add some functions into it, right? So if you have some kind of a named entity that has a bunch of properties or variables, and you have ways to modify them and predefined by you ways, those will be the actions or functions or methods, then that's an object, right? And I'll talk about that next week. But so far, structures are just groupings of variables that we can identify. So for example, in here we have a structure called parts on line 6, and on line 16, what I'm doing is I'm saying struct parts part. So what I'm saying is I'm declaring a variable called part, which is going to be of the structure parts type. Okay? So this particular part, I can provide a part name for it. On line 17, I say part.partName equals bolt. So this is how we access the properties or the variables in a structure. Right? So we're using a dot to access those. And this is very common if you've done Java, if you've done Python, if you've done any kind of object-oriented programming. A lot of times, the properties of the object are being accessed using the dot. Okay? And again, we don't really have objects just yet, but it's pretty much almost the same thing. So in there, I'm going and I'm changing from line 17 through line 20. I'm changing the properties of this object. I'm giving it a specific count. I'm giving a specific unit cost, and then I'm telling it to calculate the total cost, which is equal to these two other ones multiplied. So that is actually one of the possible issues of these earlier structures that came before objects is, suppose I accidentally go in there and I change some of these values to something that's not acceptable. Maybe I put a count of -20. Right? Or maybe the unit cost, instead of a number, I put a string accidentally. Okay, so these are possible things that can mess up my program, make it break, and which is why later on when we talk about objects, we need to provide for some kind of fail-safe mechanisms from preventing these things from happening. And that's where these functions or actions come into play. But we're not going to deal with any of that stuff with structures. Just so you know, this is one of the drawbacks of structures is you could possibly accidentally mess up the properties by just directly assigning values like you see here, line 17 through 21, through 20. Okay? On the next one, in example 2, I have another example of a structure. This time it's called a record, right? Lines 5 through 11 is your record, right? It's got curly brackets to tell it where it starts and where it ends. There's a semicolon at the end of the curly brackets on line 11. In lines 7 through 10 are your different properties for this variable, right? A couple of integer variables, a couple of float variables. And then on line 14, I'm creating a variable called autoparts, right? Which is of the struct record type. So this is autoparts. So think of it, it's almost the same way that in here we're saying int part nums. Think of the int part as the struct record part, right? So these two words are basically the type of this particular variable, the data type, if you want to call it that. Okay, so this particular program here is an example of how you can enter information into a structure. So the user can enter this information into the properties of a structure, and you can do some calculations, and you can output these, properties that are stored inside of a structure. Now the next one is an example of structures and functions. So how can we have these structures as arguments? How do we send them into a function? How do we have a structure as a parameter? To make it easier, if you look at line 15, I use typedef struct cylinder. So in other words, from now on, whenever I want to use the two words struct and cylinder, which is what I have on line 7, which is basically the type of structure. So every time I want to use one of these structures, I am creating a word called uppercase cylinder here on line 15. That's the meaning of typedef. So typedef allows you to create your own custom data types. Okay? So the data type that I'm creating here is going to be of the struct cylinder type, and I'm going to call it cylinder. Okay? So that way, now if I wanted to, on line 21, I can just declare a new cylinder structure thing using just cylinder. Okay? Any questions? Rigo?
Yes, good morning.
Oh, good. So, good morning. So, all right, so basically, again, one more time. On line 15, I say typedef struct cylinder, uppercase cylinder. So from that point on, I'm going to use the uppercase cylinder instead of saying struct cylinder. It just allows me to shorten the code a little bit. So in line 17, I'm saying that there's going to be a variable, can1, which is going to be of the cylinder type. So we're going to be able to send the cylinder structure into the function func output. Okay? And how do I send it? How do I send a structure into a function as an argument? It's on line 30. I just like any regular normal variable, right? Parentheses for the function name, parentheses the variable name, and you're sending over the structure. Okay, and you can show all those different values of the structure that are part of that structure in the function. Make sense? Questions? Okay, so this is an example, and what you're going to have to do is you're going to have to type all these up. You're going to have to get them to work, right? Hopefully you encounter some errors with them to learn better. I think that'll be good. The next one is example 2 with functions. So this time what we're going to do is we're going to be sending a structure into a function as a pointer. And actually that is kind of the preferred way. Well, the structures that we're seeing here, they're not very big. Well, when we start making our own data structures, maybe in the data structures class that you're going to be taking next, then structures start getting really big. They take up a lot of space in memory, and it's inconvenient for you to be shifting them from one place in memory to another place in memory. And that's where it becomes more convenient to just make a pointer to the original structure. So whenever you're inside of the function, you don't have to make a copy of that monster data structure that you're working with. You just have to have a pointer to that original place in memory to speed up things, right? So that's why we have to make a pointer variable. And a lot of languages who don't have pointers, they use references, which is pretty much the same thing, right? Java does not have any pointers. It uses references, but the idea is the same. We're not going to send the whole object or structure into the function. We're going to just send a reference or how we can identify it in memory without moving it around memory. So making a pointer of a structure is similar to how we're going to make a pointer of any of the primitive data types. You just use a little asterisk, right? So what I have in here is I have a structure on line 6, struct cylinder, so that's the name of the structure, cylinder, and then later on I'm going to use typedef to create a variable uppercase cylinder, which is going to be basically a substitute. Instead of saying struct cylinder, I can just say uppercase cylinder. So in here on line 15, I'm saying there's going to be a cylinder type of variable, which is going to be a pointer, right? And remember that whenever we did that with the regular primitive variables like integers and floats, you can either put an asterisk, you can either say int asterisk and then the variable name, or you can just say int asterisk. You don't really need to have the variable name. And that's what we're doing here. We're not providing the variable name for that reason, right? But it's still a pointer. So how are we going to send a pointer into a function? Or the memory address as an argument? Well, line 21, if you remember your pointers, what does ampersand can do? What does that give me? The memory address. Awesome. So I get the memory address of the can variable, which refers to some place in memory where all these different variables are organized, right? It's like a starting point. And then I'm sending that starting point into my func output, which is going to be received using this variable can1, right? And then inside of the function, if I wanted to change this, right? If I wanted to change the properties of this can, I use this notation, right? It's no longer the dot, okay? It's the little dash and greater than, okay? So the dash and greater than is how you're going to access the properties of a structure if you're doing a pointer. Right? It's confusing because most other languages don't have multiple ways to access the properties of an object or structure. C++ does. If you were to rename this or change it from a pointer, so remember that the little asterisk is a pointer, right? But if I change the little asterisk to an ampersand sign, then that becomes a reference. It still serves the same purpose. It still points to the object that we're sending into the function, but you cannot change it, right? In other words, if I had it as ampersand, then can1 is always going to be connected with the argument that we're sending into the function from the main. Okay? And in that case, in lines 34 and lines 36, what you have to do is you just have to change these to dots. So again, if I'm using ampersand sign, the syntax for lines 34 and 36 is going to change from this little arrow to a dot. Okay? And both ways will pretty much work, the same. Okay? Any questions? So this is sending structures as arguments, as parameters into functions, and then modifying the properties of these structures inside of the functions, and showing the properties from other functions. Okay? Any questions? Comments? Concerns? Okay. So, I also have a video that goes with that for the Monday class. I'll post yours as well. What you have to do is go through these, type up the examples. Since we're getting close to the end, I'm easing it up a little bit on you. So just get these going. Get comfortable with structures, and I'll introduce you to classes and objects a little bit more in depth next week. And then when we start talking, we're going to talk about seriously about classes and objects when we get to the data structures class, which is the CSIS 46. Okay, so where this thing leaves off is where we're going to start in the next class that you're going to take hopefully next semester. Okay, again, if you haven't done Java, take Java maybe at the same time as you're taking data structures or before the data structures, just because Java has lots of objects and it will make you comfortable working with objects, and it will help your understanding for the data structures class. Okay, so that's your mission for this week. Should you choose to accept it, type up these sample programs, turn them in, and let me know if you have any questions. We're almost at the end. We are at week 14 of 15, right? Next week, we're just going to finish up with classes in object-oriented programming. Week 16 is finals week. I'm not going to be here in the regular class during the finals week, but I will be in my office. And the reason for this is because they have other classes scheduled to have finals during our regular class normal hours. So I'll be there if you need me. Any questions? All right. So yeah, if you need to turn in work, turn in your work. I'm not penalizing you for things being late. Just turn it in. Okay, the sooner the better. Okay, and yeah, that's all I have to tell you for this week, and to be continued.